Good morning, everyone. Welcome to my poster presentation here at the International Materials Research Congress in beautiful Cancun. My name is Omar Vázquez Flores, and I come from the Department Metallurgical and Materials Engineering at ESICIE, part of a National Polytechnic Institute. Today, I'm going to present a research title Evaluation of Jacaranda-Based Organic Inhibitor on AP5L grade B is still exposed to produce water. Let me walk you through the most important aspect of work. As we know, AP5L grade B carbon steel pipes are essential for transporting hydrocarbons. However, they frequently operate under critical conditions and suffer from severe degradation process called flow accelerate corrosion or FACT. This phenomenon usually happens in the areas where the flow changes directions, like elbows and joints. The turbulent and highly salinous produced water removes two natural protected passivation layers on the steel, such as magnetite. Traditionally, industries use organic inhibitors to mitigate this, but they have high toxicity and elevated cost. Because of this, we need eco-sustainable alternatives. In this study, we evaluated biodegradable organic inhibitor formulated with Jacaranda extract, which is rich in alkaloids and tannins. Our main goal was to contrast steel's behavior without this inhibitor, analyzing the influence and microstructural change from engine heat treatments and the fluids impacting engine. And the methodology, moving over to methodology, we designed two comparative experiment. We machinate compounds of the AP5L grade B steel and amply and solution annealing treatment, followed by an artificial aging head treatment and the 500 degrees Celsius for different periods, 0, 500, 1000, and 1500 hours. The corrosive medium was synthetic produced water with at the control pH with at the 3.5. For the inhibited phase, we added 200 ppm of jacaranda extract macerated ethyl alcohol. To simulate two dynamic environment, we used two outlet impingement chamber. The centrifugal pump circulated the fluid on 18 liters per minute for 8-hour cycles. We designed at the time specific angles, 45 degrees and 90 degrees. We measured the corrosion kinetics using linear polarization resistance. It called the L per R, and the Tafel curves and the three electrode cell. After all, we use the ultrasonic cleaning and characterize the surface and the corrosion products using CM, ADC, 3D, optical profilometry, and X-ray diffraction. And as a result, not likely look on results. The linear polarization curves revealed something very interesting. The steels age for 500 hours show the most critical deterioration rates and aldation areas. Surprisingly, when it constructed high data, we discovered the Jacaranda invader systematically increased the corrosion rates compared to the tests without it. For example, the Eundage sampled at 45 degrees angle went from the 312 MPa without the inhibitor and 605 MPa. We did, however, despite increasing the attack, the inhibitor managed to stabilize the speed over time by promoting the rapid formation and agglomeration of surface products. We also found that the dynamic factor is crucial. The 45-degree angle maintains a highly aggressive degradation because it creates shear stresses that constantly detach that oxide films. On the other hand, the 90 degrees direct impact allows a better compensation for the protective layer, significantly reducing the corrosion rate. Or the XRD and ADS analysis confirmed that the 90 degrees stable copper sulfate derived from the pump water, and the iron oxides dominate the surface. And the 3D profilometry validates this mechanism perfectly. It showed deep where values 45 degrees and high accumulate crest and the 90 degrees. However, after removing the layers without ultrasound, we could see severe directional growth and the deep beating underneath, especially for the longer ending times. And in conclusion, to summarize, finish, we have the three main conclusions. First, the addition of this Jacaranda-Based organic inhibitor is now valid in protecting this steel in produced water environments because it increased the kinetic rates of metallic degradation still anti-passivity them. Second, the severity and the flow accelerated corrosion depends heavily on the hydrodynamics 45-degree impact is highly restrictive and it promotes constant erosion. Inversely, at the 90 degrees, incidence facilitates the disposition for the highly stable crystalline species, acting as cyclical barrier that decrease what is lost. Thought, eating, stored, allowed spitting or need. Finally, microstructurally, the engine heat treatment modifies the corrosion resistance, and we identified at the 500 hour threshold as the state heat highness susceptibility for the anodic dissolution of the material. And to finish, I'll show you the most important reference we use to support this research with this listen right here. Thank you for your time and attention. I would be happy to answer any questions I may have.